So now that we've talked about how the first part of the case study ex2 works, that was testing the interval method, let's go ahead and look at another example. And this example is going to use a bunch of other Flux operators. And it's going to do sort of a cool pub-sub-like model where we're going to have one thread that's publishing random numbers and a different thread that's going to be checking to see if they're prime. With the previous example that we just looked at, part one of this, we had a single background thread that ran every half a second, and it emitted these random numbers. And then that thread was used to check to see if they were prime. So you can imagine, perhaps, on a multi-core machine, that approach might not work as well as an approach that had one thread generating the numbers and the other thread or threads processing them. So it's very easy to scale this up to do other kinds of stuff. And again, we're going to use that from runnable technique here in order to make all this stuff work. All right, so you can find that in the ex2 project in the reactive Flux folder in my GitHub Lab Lessons repository. So we're back in my ex2 project, and you can see here that this time we're going to focus on the test is prime async method. That's what we're going to be showing in our test. As before, we register both that method and the test is prime time method with the async task barrier, and then we set those things running in the background, and we block the main calling thread till they're done, and then we print out how many tests ran. So let's go ahead and take a look at this method. So test is prime async, also uses string buffer, just like we used before. We also have a little logging, a little mechanism to log stuff. I should probably factor that out and make that a class field as opposed to doing it inside each of these methods because it could be reused. And now we're going to have some fun. We are going to go ahead and create a new scheduler, which we're going to call subscriber. And the subscriber scheduler is going to be a parallel scheduler. I'm using that word in quotes because there's only one thread in it. It's got a parallelism unit of 1. But FYI, it's trivial to change that to n, and then we can have a pool of threads doing this processing very, very easily. One of the other nice things about how Project Reactor works and reactive programming, you can elevate or scale your system with very little work on your part. Here's what the main outer Flux stream looks like. So as before, we're going to use that create factor method to make ourselves a stream of random numbers. And we're going to take a look at how that works. It works differently this time than when we did before in part 1 using the interval operation. Then we're going to go ahead and log the results. And now here's where things get more interesting. So before, if you recall, everything was done in the interval thread, in that one parallel thread pool thread. But now we're going to have one thread doing stuff in the background, publishing of the random numbers. And then we're going to have another thread, which is this thread, going to be handling them. And we're going to do that by using publish on and giving this subscriber. If you recall, subscriber was the scheduler we just created up there that had a single thread in it. So now we have one thread that's publishing, one thread that's subscribing. So what's going to happen is everything from this point downwards is going to be running in the subscriber scheduler context. What is it going to do? It's going to do exactly what it did last time. It's going to check to see if the number's prime using the memoizer, just like we used before. And then we're going to go ahead and print the results, just like we did before. And then we're going to have something fun here where we're going to use do on complete to display the results when the stream finishes successfully. So if it succeeds, if nothing goes wrong, we'll display the results. And then just for kicks, we could have combined these things, but just for fun, we're going to use do finally to dispose of the subscriber. And if we don't do that, I'll probably run the example to show you what happens if we don't do that. Then the program won't shut down because that thing is running in the background still. And then the last thing we're going to do here is we're going to use the then operator again. Remember, we talked about then before. And this time, then is going to just return an empty mono, which is a signal to the async task barrier that this asynchronous computation has finished running. And the async task barrier can then take that into consideration when deciding if it can return to the calling thread that is blocking, waiting for it. OK, so that's basically the flow. So you can see that it's similar to before, but we use do on complete and do finally here. And we also have a different way of generating the Flux stream in the first place. So let's go take a look at that. So here is make async flux sync, which is kind of a weird phrase of sync and sync, async and sync, but they're not the same meaning. So what we're going to do in this method is this is a factory method. We're going to make another scheduler. This is going to be the publisher scheduler. Once again, we have a single thread that's going to be publishing. And then what we do, and this is really, really interesting. Check out how we do this. This is fun. We are going to go from 1 to the maximum size of integers on the machine, like billions, billions and billions, like Dr. Evil. 1 billion, or actually it's more than 1 billion, it's many billions. We're going to have a range. Remember, the range method in this is like a reactive for loop. And for each of those things, we're going to convert the integer into an unsigned long. And that's just because for some God knows why reason, Flux lacks a range long method. I don't know why. Then we're going to use the subscribe on operator to say, do all of these computations starting from the range generation in the context of the publisher scheduler. So it says run that, everything's going to run in that thread, even the stuff ahead of it. Remember, that's what's wacky about subscribe on. That's the semantic. And then what we're going to do is in that background thread, we're then going to generate a random big integer. And we're going to go ahead and use the filter operation to get rid of things that are even and only keep odd ones. And we're going to take up to S max iterations of these things. So it's really not going to run for billions and billions of iterations. It's only going to run for as many as it takes to get the number of iterations that we need. And then what we're going to do is, if all goes well, we're going to propagate that up to the outer stream using next. And if something goes wrong, we're going to shut down. And if we complete, we're going to shut down. We probably could put some more error messages in there if something goes wrong, but honestly, nothing's going to go wrong here. Now, the other fun thing is we also have a do finally call here, which is going to dispose of the publisher when we're finished. And we probably could have put that here if we'd made this into a little lambda method. We could have also disposed of the publisher there, but I wanted to show off using do finally, so why not? OK, so that's that code. Now, we've actually ran that code before, and to avoid having to rerun it again, here is the results. And what's interesting about this is we ran these methods in this order. So we started off by running test is prime time, followed by test is prime async. However, if you look at the order in which they were output, the test is prime async finishes first because it's not doing it every half second. It's doing it as fast as it can. And so what it's doing, you can see we have a publisher thread, because that's what we called it. We called it publisher. And that's going to emit values as fast as it possibly can. So if you look here, unlike the one that we did before, where everything was basically a half second apart, these things are just being blasted out as quickly as they can be sent, as quickly as they can be emitted. So we're emitting a bunch of values. You can see we emit these random odd numbers. We have 10 of them. And then that's getting passed over to the subscriber thread. And the subscriber thread is then doing the checking to see whether or not the numbers are prime. And again, it's using the memoizer, so it's keeping track of this stuff. And sometimes, most of the numbers are going to be non-prime. And every once in a while, it'll randomly generate a prime number, because there's not as many prime numbers, as you know, as, well, let's see. I guess in theory, they're the same number of prime numbers if you take an infinite number of numbers. But we don't do that, so we're going to have less prime numbers generated here. So you can see that we do one thing in one thread, one thing in the other thread, and everything is happy. And you'll also notice when we're all done, it said we completed 2 tests, which means that we return from main. So that's the end of the discussion here for the ex2 case study.